Hello, hope you had a great day today. We are going to continue with graphing, and now we're going to transition into graphing inequalities, both linear and absolute value. So we've graphed inequalities on a number line, so we're going to figure out how to graph a linear inequality on a coordinate plane. So that means we have to have an x and a y. X and a y. And then we're going to learn how to graph an absolute value inequality on a graph or a coordinate plane. Again, we're going to have an x and a y. Okay, so let's get started here. A linear inequality is just a linear relation with an inequality symbol. You're going to soon see that they are not functions because there's so many values for a given x. There's a whole half a plane, okay? And speaking of half a plane, one thing that we have to do is we have to graph the boundary line. That's like graphing the equation. Let's highlight that. Graphing the equation, okay? And then deciding which half of our coordinate plane our solutions actually lie on. And we're going to use some graphing techniques that are closely associated with open dots and closed dots. If we have a dashed line, that means that we have symbols that are exclusive, like less than or greater than. If we use a solid line for our boundary line, then that means we have an inequality at like greater than or equal to or less than or equal to, the inclusive part, okay? So when we go to graph inequalities, here's some helpful hints, all right? First of all, plot that boundary line. That's just like graphing the equation. Graph the equation. Okay? Use a dashed line if you're exclusive, use a solid line if you're inclusive. Then the only extra step you need to know is that you're going to test any easy point. Any easy point that is not on the boundary line. Don't test a point on the boundary line because you're always going to get a true statement there, okay? Then once you test the point, like I like to test 0, 0, that's my go-to point as long as it's not on the line. It can't be where? The point that you test cannot be on the boundary line. So once I test it, or once I pick it, then if it makes the inequality true, I'm going to shade toward that point. Or another way of saying it is on the same side as that point. If it's false, I'm going to shade away or the opposite side from that point. And this will become more clear when we actually do a couple examples. So let's do a couple examples. We're going to graph the line x plus 4y is greater than 2. This is in standard form. So I'm going to just hop to the x and y intercepts. So I'm going to set y equal to 0. So that gives me x plus 0 is equal to 2, or x is equal to 2. That's the point 2, 0, because I plugged in a 0 for y. For my y-intercept, I'm going to put in a 0 for x, so that gives me y, 4y equals 2, y equals 1/2, so that gives me the point 0, 1/2. So I have 0, 1/2, and I have 2, 0, and then this is exclusive. The symbol is exclusive. So I'm going to use a dashed line between those 2 points. Okay, so now I'm going to, this is dashed because it was a greater than symbol without the equal component. Now I have to check how to shade. How am I going to shade it? All right, pick a point, an easy point that's not on the line. I'm going to pick 0, 0. It's not on the boundary line. So I'm going to plug in a 0 for x and a 0 for y and see if it is true. Is 0 plus 0 greater than 2? So is 0 greater than 2? No, that's false. So instead of shading towards 0, 0, I'm going to shade on the other side. Here's 0, 0, but it's not a solution. So nothing on the same side is a solution. So we're going to shade over here, away from 0, 0, or on the opposite side of the line from 0, 0. Okay? Now we're going to graph a line that's in slope-intercept form. And because of this form, I'm going to go ahead and use my y-intercept, and then I'm going to use my slope to graph up a line, a point to the left and to the right. So my y-intercept is the point 0, 4, and my slope is equal to a positive 1/2. That means my line has to be going uphill from left to right. So I have 0, 4, 1, 2, 3, 4. And if I go up 1, I have to go over 2. And if I go down 1, I have to go over 2. Okay? Do I want to use a dashed or solid? Well, I have a greater than or equal to symbol, so I'm going to use a solid. And I'm going to connect those points with a solid line. Now I'm going to test a point that is not on the graph. I'm going to test 0, 0. You can test any point you want. I'm going to test 0, 0. I'm going to plug in a 0 for y. Is 0 greater than or equal to 0 plus 4? Is 0 greater than or equal to 4? Nope. So that's false. So instead of shading towards 0, 0, I'm going to shade away. So I'm up here. Okay? So I think our last example is a tutor company specializes in helping students with a combined SAT, verbal, and math score of 900 or less. 900 or less. So that means it has to be less than or equal to 900. Well, what does? Well, if X is the verbal score, it says combined, so that means we're going to add. So X plus Y has to be less than or equal to 900. So we have to graph this inequality. And we're going to, I'm going to use the slope intercept, or the X and Y intercepts. So I get the point 900, comma 0, and my y-intercept is the point 0, 900. So I'm going to make each one of my squares 100. So this will be 900 here, and this will be 900 here, right? And there's my y-intercept, there's my x-intercept. It's inclusive, so I'm going to do a solid line. Connect them. Sorry, I missed just a little bit. And then we have to decide where to shade. So I'm going to test the point 0, 0. All right. Is 0 less than or equal to 900? Well, that's true. So I'm going to shade below the line or towards 0, 0. Okay, so I'm going to shade here. All of that. Okay. So now they want us to look at a student with a score of 470 for my verbal. Well, this is, let's make this verbal down here. It doesn't matter with this. And this is math here. So I need 410, 100, 200, 300, 410, and then 470. 1, 2, 3, 4. So here it is. Is it in the shading? So would this be a target student? Yep, it does describe the target student. Yes. All right. So go ahead and watch the next video about graphing absolute value inequalities. Thanks for watching.